Hello, everyone. Welcome to this meetup. Really glad to see so many people here. New faces, it's always a good thing. As you know, in BC and Rust, we are always looking for people willing to share talks, ideas. So if any of you have something that want to share with the community, please get in touch with us, and we will prepare some event for you. So without further ado, I'm going to make this super short. I'm going to introduce Fran, which is going to speak about Adevinta, our host today. Hope you enjoy the session, by the way.
Okay, so I'm Fran. There's a lot of new people. There's a lot of people who I already know from other editions, but there's a lot of new people. So I think we can go a little quick over what is Adevinta, because I mean you've been joining this building, and I guess you want to know what it is. I will be super quick, less than a minute. And that's it. I don't know, it's quite okay. Let's do it. There's a fancy way. These are corporate slides. You have to take it into account. But yeah, it's a champion for sustainable commerce. Basically, our business is marketplaces. We own a lot of marketplaces that are doing selling stuff. You can see some of the brands here, and I will show you a little more or less. But it's we have a lot of second-hand things that are being sold, like e-commerce and all these kind of things. Also other verticals I will show you later very quickly. So we are the leading online classifieds group across Europe, okay, with presence in France, Germany, Spain, Italy, and Benelux. We have this. So what do we care about in Adevinta is a healthy planet and society. Looks fancy. Shaped by sustainability and other criteria, and yeah, help things get a new purpose and to create a perfect matches through our local, lovely, international connected marketplaces. These are the numbers. For me, they're a bit impressive. I don't know about you, but yeah. So this is the number of visits that we have worldwide per month. Yeah. We have 25 products in our portfolio. The revenues are quite high, at least for my standards, and we're quite big in terms of employees as well. It's a big company. Do you want to add something? We have colleagues here. So these are the brands that maybe you are familiar with, especially if you're not Spanish. But that means Leboncoin, Mobile, Kleinanzeigen, Marketplace, Fotocasa. All those are the brands that we manage. Yeah, we can see the market positions as well. So, for example, we are like primaries in motor in Spain, but we are secondaries in terms of e-commerce and all this, and housing and all the verticals. So these are the verticals. We have 3 verticals: mobility, cars, and everything related to cars, as you can see by the brands, e-commerce, second-hand items, and real estate, housing, and, also the other ones, the emerging are also in these verticals. I like this slide because as a big company, we care a lot about diversity, equity, inclusion, and there's quite a big effort on this front. These are the people that are trying, and we have a team that is always striving to make it better. And yeah, well, this is we have a full platform of people working on trust and safety, on how to make all these platforms reliable, in the sense of you don't get shafted or you don't get problems with this kind of thing. This is the numbers very, very quickly. I think it's a bit impressive as well. I don't know how, don't try to, I mean, I cannot enter in detail about which of these, what do all of they mean. I would need to talk to the expert in sustainability, but those are the numbers of how many things we have equivalent, we have recycled, thanks to the e-commerce and all the initiatives we have regarding sustainability. And that's it. Only one thing, all the ones that didn't enter with one of these will need to signal the lady on the front, okay? So you will not be able to get out. You have to call attention in order to get out, okay? And that's me.
All right.
Nice. Well, hello everyone. I'm gonna be your host tonight, so we'll walk you through the talks that we have on the schedule, and I will be moderating the panel at the end. As you see from the titles, the topic today is Rust in production. So we found two speakers. One is Gleb, the other one is Matilda. We're going to speak about how they're using Rust specifically within their organizations, challenges, opportunities, and their journey throughout the adoption. My name is Luca Palmieri, for those of you I haven't met before, and I work as a principal engineering consultant at Mainmatter. And I've been in the Rust community for a few years, and I'm probably best known for being the author of this. Now, Mainmatter, who organized this event to go, together with BCN Rust, is a consulting company based in Germany who operates throughout Europe. In particular, we focus on Rust on the backend. So we use Rust for anything related to API services, workers, data pipelines. If you have something that runs in the cloud and you want it to be fast and performant, we can help you with that. In particular, we look at training. So there's a lot of training material you can find. You might have seen the 100 exercises to get started with Rust, which circulated a couple of weeks ago. We wrote that. I wrote that, actually, but I might have wrote that. We do team augmentation. So if you have projects related to Rust when you need to upskill people while the project is ongoing, or you need extra capacity, we can help you with that. And last but not least, we do code audits or code reports. So we jump in if you have projects that need a second set of eyes to make sure things are the way they are. Now, I don't want to bore you too much with us, so we'll go back to the schedule. And without further ado, we'll get started with Matilda. Now, one thing on the way this event is going to run, we're not going to have Q&As after the talks. All the questions will go into the panel. So if you are listening to the talk and if you have a curiosity or a question, write it down, and then you'll be able to ask it directly when the panel runs. Without further ado, big show of hands for Matilda, and she'll get started.
So, hello everybody. Really nice to see all of you here. My name is Matilda Smeds. I'm working as a senior software developer at a company called Matchday. And I'm here to talk about how we are using Rust to build games for the 5 billion fans of football. I'm calling the talk Excitement of Football and Reliability of Rust. But to be honest, I wanted to call it Excitement of Rust and Resilience of Football. Because, while Rust is relatively new, the first version of Rust came out in 2015, football is, in one way or another, it's old. There's archaeological evidence that some sort of a ball game was being played in Central and North America 3,000 years ago. And when I look at my son just kicking the ball without knowing that football exists, but he sees the ball and for him it's pure magic to kick it, it's no wonder that football has become what it is today. We have more than half of the planet watching football, being enthusiastic about football. So in this talk, I will first explain a little bit what Matchday is, what I think what sets us apart as a company, how we're different. Then we will look into the game we're building. First, what the experience looks like for the player, and then what the architecture is on the backend side, because backend is where we use Rust. The client is Unity, built for Android and iOS. And then I also want to discuss some experiences in navigating the ecosystem when developing stuff for backend in Rust, and yeah, that's going to be the talk. Let's go. Yeah, so Matchday is a company founded 2 years ago, and I think if I had to say just one thing about Matchday is that we have collectible cards with actual FIFPro IP, so we can represent over 60,000 footballers in their name and likeness, and so we have cards. But we have though only the 4,000 maybe better known footballers currently on cards, and I think one point that's kind of interesting, was super interesting for me at least because I didn't know this, that there is a platform called Workato that serves over 200 different statistics for each footballer in each professional football game. Maybe not in all leagues, but that's a huge amount of statistics. And we actually crunched those numbers and try to simplify it so that we can create casual football management game where the players can actually, have data that's easy to understand, while we are basing the our footballer rankings and statistics on their actual performance. So I think that's kind of cool. And here we can see our brand ambassador, Alexia Putellas, whom some of you might know. And then Lionel Messi, whom some of you might know as well, who is actually one of our investors as well. And one thing that's cool about our system is that as we compress those over 200 statistics into these simple stats, we have also calibrated it so that actually, at least in our game, the best female footballers and the best male footballers can play side by side, and you can build your dream team of the best players from both sides. Yeah, so I think that's cool. And our team is super small. Well, not super small, but it's actually super international. It's kind of small, though. We are just 43 people as of last week. We're hiring, though. A shameless plug will come later. And we are spread across 21 countries and 4 continents. We mostly work European and American hours, though. But still, I think that's cool as well. So what about the game? Our game is called Matchday Champions. It's a casual football management game. One key aspect is, of course, the cards. When the player signs up, we give enough cards to start building the team and start playing. And then, of course, we hope that the player might want to buy more cards or swap them or receive them from a friend or something. And then, let's see. So this is our shop experience, more or less. Here we have a player buying a card. And it's messy. This is not craziness, but messy it is. And now the player has the card in their collection. And then we have the football match experience, which is, it's super casual, it's lightweight, it's colorful. We have wanted to pack the excitement and emotions of football in this experience. So it's a mobile game, right? That's what the client side looks like. What about the backend? So next I will be showing you an architectural diagram. Just take a deep breath, okay? So here on the left side, we have the services and the data storages of the game studio side. Whereas on the right side, we have what we call the platform, which is the marketplace for these cards, and also a couple of external services quite typical for casual mobile gaming backends. And here we have highlighted the core part. Actually, everything that happens in our game goes through the core. So we serve a GraphQL API for the client, and then that resolves the queries for the different services we have in core. They talk together with gRPC, and we have one service for users, another one for footballers, one for squads, one for matches, and one for rewards. So we have tried to keep it a little bit modular, a little bit of separations of concerns. That being said, the database is still shared. It's a Postgres database, and some services are like more focused on their tables, whereas others share more freely. But it's been working for us so far. Then we have the streamer, which is a service that takes care of the match experience. We have GraphQL APIs there as well. Actually, on the game studio side, we don't have REST at all for right now. add traditional REST API. And then we have WebSocket interface as well, so that the client can send actions during the game, and we can serve maybe responses faster. Hopefully, that is the intention at least. And then, of course, the streamer talks to the core. We fetch data for the match, and we store outcomes for the match and the actions taken during the match there. One thing which I think is really, really cool is how we are using Redis here in the streamer service. So we use a Redis data structure called Redis stream, and in player versus player game mode, you know, the player who contacts the server first will be the primary streamer, and so each of the nodes contacted for the same match will try to create a Redis channel. If it already exists, it means that somebody's already the primary, one node is already the primary, and the other node will have to be the secondary node. And then the secondary node passes player actions to the primary node executes the logic and serves what is being streamed both to the secondary node and to the client through the WebSocket, and to the secondary node through the Redis stream. Then a little bit more simple service is the scheduler, which is just a simple Tokio server that executes scheduled tasks. So, and currently the only tasks it's executing are scheduled notifications, and then also managing the daily drills, which are different sets of exercises or tasks or quests, if you may, that the player can complete during the day. And to close the loop, we need to talk about the platform side. So IAP means in-app purchases, which of course are super important in a free-to-play game. So the client integrates with the REST API of the marketplace so that the player can actually buy things, put a card on the marketplace, swap, sell, gift cards. And then when any of these things happen, for instance, a player buys a game, buys a card, on the game studio side, we have to get this information to be able to show the card in the player's collection. So the player buys a card, platform puts an event on the queue, card has been bought. We have this event handler service consuming from the queue, which is SQS in our case. And then that stores the card data on that user's roster or card collection. Okay, so that's the architecture. That's the architecture. Next, we're going to look at the crates we're using. I thought maybe it's interesting, or not. Maybe there are no surprises at all. I don't know. But basically, everything we do is Tokio. All of our services is Tokio. We didn't really even look into other options. Tokio seems to be really established right now, and mostly, with a little bit of a caveat, mostly it's been good building with Tokio. I will get back to that later. Then our core services are built with Axum, and the gRPC, rather perhaps unsurprisingly again, is Prost and Tonic. Then for the GraphQL APIs, we use Juniper Warp. And here, the reason why we do this is because this combination actually worked. We were able to make Juniper Warp work. I remember trying last fall, also with Juniper Axum, and even with the examples, I was not able to make it work in the limited number of hours you have on a commercial software project. So Juniper Warp it is, even though personally I have to say I find Axum more intuitive. For the WebSocket we use Warp, and that has been nice. WebSocket has been easy to use, no complaints about that. And for the database connections, SQLX, of course. Of course. Well, it's funny, giving this talk, because I don't know you are developing with. I'm just talking here what I'm developing with, and somehow making the assumption everybody else is ending up with the same crates. But yeah, again, very established choice. And it's been, again, mostly good developing with SQL. More on that later. Then for Redis, we use mobc for managing the connections, and Redis crate for everything else. And in logging metrics department, no surprises there, tracing and metrics, we have Grafana, Prometheus, and CloudWatch in our mix. There are also some other smaller crates we built with that I just wanted to give a small shout out there in the lower part of the slide. So we use anyhow. We probably even overuse anyhow, because I see that it's become sort of a standard pattern for us just to do all the errors in anyhow. After all, we are not building libraries. We have crates in our workspace setup, but thinking about what should be the error types seems complex. So we use anyhow pretty much for everything, and then push potential retries, logic, and stuff like that back into the API client crates. So the API client crate owns the retry logic. The rest of the service doesn't know what type of an error it was. It doesn't care. It logs it. It either fails the request or continues as if not much has happened. Then we use .env and env-config. These have been practical both for setting up the tests and the services. We are recently experimenting with backend for retries. I don't have enough experience on this yet to really say if we like it or not. It's our game is in beta, and it's a recent addition. But we want to build on that, or find something similar or something better. Then of course, you know, the whole Saturday anything, really, we have a lot of Saturday things in there, and yeah, and some other crates as well. But I thought this was the most important ones. I think the image credit is not showing, but this is from the Giphy account of Ajuntament da Girona. I wanted to add a little bit of local flavor, because I think this football exercise is just so cool, and maybe it explains a little bit why Catalonian and Spanish football players are so good. This is what they do since they're very, very young, I think. Also, this is kind of an preamble for the more practical part, where I share about our practical experiences. So first of all, I'm going to talk about Rust, and then navigating the ecosystem, and then let's see what else is coming up. So, you know, for me, Rust was a dear hobby long before, or at least that for quite some time before I could even dream about working with Rust. And now I've been working professionally, developing Rust full-time since July last year. So of course, it's been an eye-opening experience in many ways. And I have to say, I still love it. I love that. I love the rich enums, all the things you can do, how you can package things differently using the rich enums. Result and option are great. I think any aesthetically typed language should have that. Good riddance, null objects. Pattern matching is great. I love that Rust has actually like native functional iterator and collector handling patterns. Those for me are huge pluses. But then of course, you know, I entered thinking that maybe I know already quite a lot of Rust, but it turns out I didn't. So it's been a learning experience also. First you learn to borrow things, and then at some point you realize that, hey, these lifetimes actually, maybe there's something I don't quite get about them. So you need to put in the effort to learn. And when you learn, whole new views and landscapes open, and it's fantastic. Then this has been a huge practical advantage, that you can actually refactor without worrying too much about how it's going to go. one thing though, I noticed that I can't refactor in the style I might have refactored in other languages, because Rust complainer will just complain a lot, and it's like an avalanche of complaints, and I can't deal with that. So I kind of found a strategy. We had a case where we roll the match outcome, right? There are probabilities which are affected by the stats and the position of the stars and so on. But we roll the match outcome, and we wanted to do a reroll as well, and a couple of changes here and there. But this logic was scattered across several services, so I knew I had to refactor before trying to even make those changes. And the only way to make it happen was to actually make a plan beforehand, which probably is a good idea anyway, and then find a strategy. How can I work with the compiler step by step so I can get through this quest? And I found that the best way for me was to move the structs and enums first, go with the data first, and then in the smallest possible pieces, always fixing the references, always compiling, always committing any progress. And then when it came to actual method calls, I would not just change the old method directly, but add a new one beside it. Call the old one old, and the new one new, and then see that if that compiles. And then after that, just change one by one the references. And after 5,000, I'm not exaggerating here, 5,000 lines of changed code, everything worked.
Okay.
So I think this is one huge point for us, huge bonus for us, that I see less regressions with Rust than with other languages I've worked with. I come from a .NET project from before that, and though it was a good project in many ways, I see less regressions now. And more than anything, I don't see any more null pointer exceptions, which is fantastic. We have had a couple of panics though. Fortunately, our QA catches them, or we catch them ourselves, or they've never gone to production, not yet, at least. But yeah, it's good. One thing though is that you have to invest quite a bit upfront sometimes, because we have a system where we have types for the DTOs from the external APIs. We have types for the database, the stuff in the database. We have types for protobuf. We have types for GraphQL. And any change you want to make in there, it's going to cascade. So sometimes making these changes can be a bit painful, but it's like an investment you make upfront to then later have code that works most of the time. And yeah, this is one thing I've found in our code reviews, because if I compare this world to the .NET or Java world, in there, it seemed sometimes that classes had like this gravitational pull that would just pull all the logic into the class, and the classes would become very big and huge. And sometimes you would have complex interaction patterns with the base class and the child class and so on, and it could become hard to manage. Whereas in Rust, sometimes it feels like it's the other way around. Sometimes it feels like the struct, even you can implement implementation blocks for structs and enums, and oftentimes you should. But it seems that there's like kind of an opposite pull. Sometimes the data objects are like very bare, and the logic just wants to go to whatever the endpoint flow is. And in our code reviews, we try to fight this, because for maintainability, code readability, a lot of the time, it's still a good thing to keep the data and related logic together. Then about navigating the ecosystem. It's not going to be a sad story. It had a happy ending. But you got to be careful with Tokyo. You have to check if the crates are safe to use with Tokyo. And even if the crate is like great with Tokyo, it could be even made by the people who make Tokyo. You still need to check that the methods you call are safe to call with in async code. So we have burnt our fingers a couple of times with this. One case was, I remember this this early prototype of an actor model where each service would be kind of an actor which would manage its data, and we would keep that data in memory, and then it would be flushed to the database every 10 minutes and something, really ambitious thing. And we managed that hot data in memory with a trait called DashMap, which on paper, I see knowing nods there in the front row. On the paper, it seemed good. Yeah, yeah. And we read all the warnings on the documentation. It has a lot of warnings. And we thought we were doing everything right. And everything looked good on, locally. But anytime we put the thing under more load, like not even a huge load, let's say a couple of concurrent users, the thing would deadlock really fast, and we never understood really why. And then if you go into the issue tracker for DashMap, if you go to Tokyo Discord, you will find that a lot of people are having problems with this crate in particular. So this makes me really think that there are some crates that don't gel well with Tokyo, that you can do absolutely toxic cocktails with it that will kill your application. And the other story, it's more lenient, but it was kind of curious. Anyway, so the first time I wanted to instrument our services, I chose tracing, right, from Tokyo ecosystem. And of course, innocently enough, I tried to create a span with span entered method.
Yeah.
And it turns out that's not something you do in async code. So locally, everything seemed fine. But then on the server, some spans would not, some log lines would not have spans at all, whereas others might have 4 or 5 spans unrelated to that log line, which made the logs completely usable. And at this moment, I found a nice repository from our host Luca here, called Rust Telemetry Workshop, where he shows how to instrument async code correctly with the instrument macro attribute. And with this small change, the logs were useful again. So, yeah. So you have to search, you have to ask questions, you have to be resourceful. It's not like with .NET where you can go to the Microsoft documentation and most of the things are just served on a big platter and then you know what's there and you pick from there. Some of the resources we have used are Discord. I think on Twitter and Mastodon you also can find stuff, but Discord, especially Tokyo Discord, has been useful for me. Even if you don't ask a question, you can just search. Then Rust Reddit is good. Stack Overflow can be useful also at times. There are some obscure old Rust programming forums. If you find a match for your use case, it could be interesting. So you kind of go through a lot of stuff and you try to triangulate and understand what is real and what might work to find the good recipes and avoid the bad recipes, right? So I need to be maybe a little bit faster, but it's hard to have a talk at this time about AI without at this time of human history about programming without mentioning AI. So I think large language models are especially useful for, in the case of Rust, where you have a lot of concepts you need to learn. So you have a patient teacher who can explain you whatever, basically. And as long as you stick to the Rust core language, the advice can be pretty good. Copilot can be useful, except of course, at times it isn't. There are crates where it cannot give anything useful output at all. And then some advice from these AIs can be plain dangerous. I mean, if it's difficult for the human to discern what works well with Tokyo, it's difficult for the LLMs as well. So you still need to read the manual, you still need to read the documentation, and that's not enough. You also need to know if that crate is actually something anybody has had good experiences with in the Tokyo ecosystem if you're building with Tokyo. Also, code conversions are not great, at least not yet. Depending on from where you convert, of course, but maybe in the future we will have LLMs built specifically for Rust or built specifically for Tokyo, and that would be a whole another game. So some takeaways from this talk: pick your crates with care and read the manual when using new methods in async code. Also, I think this is maybe a personal opinion, but when you build a lot of code in short time, things can get messy. And I think Rust offers a fantastic opportunity to avoid that messiness a little bit, push back on the messiness, because you can be refactoring and not worry that much about the outcome. So we have never had a regression due to refactoring. There have been other kinds of regressions occasionally, but not due to refactoring. So a little bit of refactoring, like even small things here and there, super useful. But Rust, if it gives a lot, it also takes something. You have to be willing to invest in yourself and do extensive code reviews. And also sometimes you need to invest even in the ecosystem. If I wanted SQLX to support multiple databases, which I really wish it did, maybe I will need to do it myself. So was that it? No, actually, because we're hiring. So this is the job ad, ask me anything. We do require some Rust experience. The technical task there's a small technical task, but it has to be in Rust. But you don't need to tick all of the boxes. So if the list seems tall, don't worry. If you have some Rust, if you're interested, come chat to me. You can find me also on LinkedIn or matildasmeds.com. My simple webpage. And that's a wrap. Thank you.
And then we'll follow, well, first and foremost, as I said before, there's no Q&A right now. So if you have any questions, jot them down. We'll transition straight into Gleb, who's going to talk once again about Rust in production, but this time at a different company, which is Workato. So give him a show of hands and let's see what he has to say. Hello? One. Yeah, can you hear me? Does it work? Yeah, okay. Hello, everyone. Thanks for joining. So let me introduce myself at first. So my name is Gleb Pomykalov. I'm the engineering director at Workato. So I work with Rust since 2017. Well, I also spent a couple of evenings creating releases.rs. Probably some of you know this website, so I found it hard to learn what changes are going to happen in the next version of Rust. So this is kind of a small website which compiles this. So yeah, several words about Workato. So Workato is a company. We are working in the area of IT automation. So we basically build a platform which helps IT department and maybe some other departments to build automations using like different cloud services and internal services of Workato, maybe on-premise connections and things like that. We are focusing on large enterprises. We are kind of a leader on the market. So this is like a Gartner quadrant. There's a kind of a business metrics where you can see Workato is in the top, the leader in the market, along with a few other companies. This is like a 10 years old startup, pretty late stage startup, but still startup, so we didn't enter the IPO yet. Yeah, we are really heavily focused on reliability. That's probably the biggest specific of the company. So since we work with the data of large enterprises, so it's extremely important to be secure and to be reliable. We have large hubs in US, Europe, Singapore, India, and we are remote friendly. Actually, we are hiring around the world. So yeah, here is like the main concept of Workato platform. This is called the recipe. So recipe is basically a sequence of steps where we can work with different external or internal systems. So for example, if something happens, I don't know, whatever in Salesforce, we can do some actions using the data from Salesforce. I don't know, create a file somewhere or send a message to Slack, MS Teams, whatever. There are like hundreds of integrations, and we also support building custom integrations.
Yeah, so this is kind of a low-code platform. So you don't need like very specific skills to build pretty complex workflows. Actually, if you look into our customers, at the beginning they thought that there would be like several steps on recipe. So now we have hundreds of steps on many recipes. So this is pretty complex systems. So we do, well, I just told about recipe automation. We also do API management. We have on-premise integrations, some products in the area of AI, low-code applications, and we have some homegrown services which can be used instead of like external integrations. So just an example, instead of using S3, you can use our internal file storage to store files and to work with files. So I'm representing the emerging services team. So this is a team who preliminary work with Rust. Sometimes we have to go into other technologies, but we are not really happy with that. So yeah, the team was formed like 2.5 years ago.
Is that right?
Not hours, yeah. Yeah, and currently we have 9 engineers together with me. So yeah, we mostly work with Rust. Currently we have 5 production services. We have 1 production WASM library, which is used in several other components. And we are working on new services in the stage of prototypes or early development. Here's the example of the service we are building. This one is built specifically with Rust. So this one is called table storage, very complex one. Actually, so we provide the way for our customers to create tables and to upload, to actually manage the table, manage the data in the table, query it efficiently, update and sort records, delete records. With pretty big limits, so we allow storing up to 1 million records by default, which can be extended. And we allow storing up to 100 columns. And so everything should work really well, efficiently, and with high performance. Another example is file storage. So the file storage is actually something, you may think about it as an alternative to S3, but in fact it has some advantages over S3 because we support very specific use cases which are usable in our platforms, like good integrations with recipes, so we can watch for changed files, we can react on changed files, we specifically support CSV file type and can efficiently access CSV file, derived schema, and things like that. So our goals when we build our service, they basically comes from limitations and specifics of Workato. So for example, responding with internal server error is mostly always treated as a downtime or incident. Sometimes we have requests from our customers which go to support to actually investigate why, like several weeks ago, we had one erroneous response by the services. And we go to logs, we have to provide the RCE for that, and this kind of problematic. So we can't just be, so we should be very careful when building our services. We should treat, reliability very seriously. Well, in addition to that, we should still drive innovations in the company. So actually, our team is responsible for building most of technical innovations in Workato. So others are mostly dealing with existing long-running platforms, but we are building a lot of new products. And we have to really move fast, starting from proof of concept toward production services. So sometimes we start with some ideas which we don't really understand how we can implement it, or if it's possible to implement it or not. We start from POC, then check if it's possible, and then we go and move it towards production. We focus on high performance and scalability, and really another important aspect of it is security. So actually, security requirements are very serious in Workato because we work with customers' data, and customers are not just some user, but it's actually a large enterprise which have really critical data stored on the platform. So we have to encrypt. We actually have like a special system to manage keys, hierarchy of keys. We should encrypt all the data we store, like permanent data. And this is a lot of pain to implement this. So yeah, I would like to, based on this experience, very specific experience, I would like to share some best practices which we think really reasonable for most of Rust developers who want to deliver code to production and deal with it. Yeah, so this is basically a very first step which I suggest to anyone who wants to build the service and deliver it to production. So enable LTO and change the memory allocator to gmalloc. So this is basically a very cheap way to improve the performance of your code. Another important thing, especially if you are dealing with multiple repositories, is to share the code. So you should never repeat yourself, right? So if you share the code, it actually provides you the way to move really fast. So this is a real example of one of our dependency in one of our products. So we have a repository called Workato common, where different features actually represents different capabilities which we can enable for the product. So here we enable like things specific to server, HTTP servers, APIs, entities, Redis, and things like that. So another important concept which I suggest to use for most of you is to build self-documenting code. So this is the example of, so we use Poem web server. So it's not that popular as Axum, for example, but the real good thing about it is that it can generate the OpenAPI specifications from your types. So you define Rust types and it generates specs for you. So this is the example of such type with a derive object, and we define the type. It will translate to OpenAPI specification. So anyone can then use Postman or other tools to do the queries according to the schema. Another example of self-documenting code is to use Gleb. So, yeah, probably most of you know what Gleb is, right? Yeah. So Gleb is a tool is a crate to actually generate a command line interface for your application. And the good thing about it is that it can work with environment variable, and it provides the way to document your command line interface for the user. So this is the help. Actually, you call like spawn with help, and we have all the options which we can pass to the application. So for example, we use this to automatically identify changes between versions. So we just take the previous version, and then we release the new one. We compare these helps, and we see all the changes in the public interface of the application. So it really helps with planning the releases, and it always helps when you actually run this somewhere, right, in the Kubernetes or whatever it is. Yeah, let's move on to other aspects of it. So more about code. So what we came up with is that it's really helpful. Actually, it was mentioned in the previous presentation also. It's really helpful to have different layers of types. So for example, let's imagine we want to accept a document from the API call, then work with it somehow, and then store it into the database. So instead of having like just a single type document and implement serialization, deserialization on it, implement some business logic on it, and implement some OpenAPI specification on it, instead we built 3 types. So the first type is API document. So it is built specifically for Poem and specifically to build OpenAPI specification. So there could be some, specific things which you have to cover to make it compatible with OpenAPI. So it may not be completely like nice enum in terms of Rust or things like that. When you work with this data, with the document inside your data, inside your functions, inside all your internal layers of business logic, prior to that, you convert from API document to data document. It's typically a failable conversion because it can return some errors. Some types are not compatible. So for example, here we can see that document name it can be, typically when you write the production code, you need to introduce some limits. So name is probably limited. It's not like megabyte in size, right? So we do this conversion. If it doesn't match the rules behind document name, it will fail. So you end up with working with data document type inside inside your business logic, and you are sure that it is correct in terms of types. So now it is impossible that this type holds some incorrect data. And then we have another layer called stored document. So this is how we serialize the data and store it into the database, or whatever, database, S3, whatever you choose. So the big difference here is that we actually have to maintain backward compatibility compared to data document. Data document can be refactored in any way, and we don't lose anything, so it just works, right? But if we refactor and change the stored document format, the serialization format changes, and we are not backward compatible with the previous implementation. So as you can see, different layers have different limitations, and this is why it is so important to actually define your types differently on different layers. A few words about architecture. So typically when we start, we have a very simple architecture. So some services are really small. They can have like, I don't know, 2 API endpoints, and there is no reason to make it complex. So let's say we have API layer, and then it just goes to a single service, which have a specific function per each API call, and then we do something in the storage, maybe some small business logic. We go to Redis, we go to the database, whatever it is, and this is pretty simple. So we always start from that. Once it becomes more complex, we start introducing some elements of domain design. So there could be multiple domains which are splitted by some business logic, some area, and they can have multiple repositories inside. Each repository will have its own storage, and domain service may actually work with other domains through infra services. So this is a part of domain design. So I don't want to focus on that too much. So if you're interested, just you can go and learn these patterns. How we test. So actually, out of different options of testing with Rust, well, for sure, some tests are sometimes it's reasonable to write unit tests for very isolated small components. This is fine. But when we test on a system level, when we test scenarios, so we prefer to use Cucumber. So Cucumber is based on the language called Gherkin. So it provides you the way to actually define tests like that. So the sequence of text lines, which can be parsed by special definitions, and perform particular actions on the API level, for example, right? So this is the real example taken from one of our repositories. So this is it's really easy to read it, and after some additional instruments like templating and things like that, it becomes really useful. So in addition to that, we kind of very pedantic, and we enable all strict checks by Rust compiler and by Clippy. So I'll actually focus on that a little bit later. So yeah, another interesting fact about tests, we really believe in randomization tests. Is anybody familiar with the fuzzing prop testing techniques? So basically the idea is that sometimes you can't just test all the scenarios. So sometimes you just want to make sure that some random input works with your functions. And there are basically 2 approaches. The first one is simple. It's called prop testing. So we just put random data, and that's it. Just do like many 1,000 of tests with random data and check some invariants. So for example, you serialize random data and then deserialize and check that it actually equals. The initial one equals to the resulting one. Fuzzing is a little bit more complex concept. So the idea is pretty similar, but in addition to that, we get instrumentation of the binary, and the randomization happens not completely randomly, but based on the coverage and things like that. Yeah. So the nice thing about Bolero is a crate. is that we actually just define a single test, and then we can run prop tests or fuzzing with it. So it's just the same interface. Other approach requires like using separate crates for prop testing, separate crates for fuzzing. So this is why Bolero is really nice. And in some projects we use it really heavily. Actually, a huge amount of tests are written in this way. A little bit about CI. Actually, we pay a lot of attention to hygiene for our projects. So we check just everything we can check in the CI. So here are examples. So cargo format we use nightly because of some unstable features. Clippy, check for typos. Running benchmarks in CI, running load tests in CI, enforce conventional commits for commit formats. For release automation, we use git-cleave, nice tool for built in Rust community, right? Built in Rust. So we actually built changelogs with it. We have new service template stored and tested like each time, and which can be used with cargo generate. We check for unused dependency with cargo UDEPs. We check code coverage with LLVM Cove. We do security check with cargo audit. Other type of lints, whatever we use, like Gherkin lints, what else, like some Python script lints, whatever is possible, so we test everything. Another useful tool I didn't mention here is Cargo Hack, which actually support running different cargo commands with different feature sets, different combinations of features. One of the well-known problems in the Rust world is compilation time. Actually, we find it very interesting because in terms of compilation time, we have like very specific part of the team who are always unhappy with compilation time. Others don't care. So I don't know why it happens, probably some specific about the characters of the person. Maybe it's hard to wait or something like that. But generally, so this is the hack we do to actually speed it up a little bit in the local development. So basically it's Ccache, a nice project by Mozilla. So we can run it even locally, so that at least, for example, different projects reuse the same compilation artifact or the same version of crates between each others. And another good thing is to use LLD as a default linker. So actually LLD is faster than default one. So LLD from LLVM. Ccache is also enabled on all CI checks. So it really helps it actually speed things up. So we love Rust. Actually, we are very happy with this programming language. So we don't feel anything bad about it. So typically people say like, yeah, it's good, but there are some problems. Probably we will deliver slow and things like that. Actually, we don't see anything like that. Actually, we see that we are pretty fast. We are faster than other teams. We deliver good quality code. We don't face issues with borrow checker. Mostly we never deal with it, to be honest. Yeah, but there are some things which we can think may be a little bit better. And I think it's my opinion. So I think we can make it a little bit more stricter. Actually, the best characteristics of Rust is about strictness. So each time we soften this, we end up with issues. So here are real examples. This one is not real. That's a buggy piece of code. So we have a struct called flag, and inside there is a field on, which is Boolean, and we have a function which switches the flag from true to false, from false to true. And then we change it 3 times in the loop. So you see where the bug is? Yeah. How do you think? Will it compile? Yeah. Yes, it will compile. Actually, it compiles, but after changing the flag 3 times, it's still the same, right? Why is that? Let's change the code a little bit. It's mostly the same, but we removed the copy, right? Copy trait from it. It's not longer compiles. And actually, the error message is pretty clear, right? We moved the flag into the loop, into the first iteration of the loop, and they can't use it after that. actually it properly figures out what is the issue here. So we removed copy and get a more correct version of it. So after that, it's easy to fix, right? So we shouldn't capture flag into the switch flag and take the mutable reference to it and change the reference, right? So the result is correct now. So what we see, actually, that's a very interesting one. So copy versus clone. So copy means that the type can be copied in a sense of like memory copy, byte copy, right? Clone means that type can be copied by some custom implementation. So it makes sense to say that the type is copy just to actually show that it can be copied in a sense of memcpy, right? But it changed the behavior, which is not good. So actually, copy made the Rust compiler pass in the buggy version, pass the copied version of the flag several times into the function. So it seems like this is the example of not very strict behavior. Actually, what I think could work here is that if we introduce the copy keyword into Rust, so instead of implicitly change the behavior for copy type from move semantics from move to copy, we could signalize that we want to copy this value instead of moving it. Well, this is one example. Let's go to another example. Silent errors, which is actually based on the real incident. So do you like this code? What could go wrong, right? So we just need to convert seconds to milliseconds, right? So this is actually how it looked, right? It was I32, which is not a big integer, right? So it's limited. So when we multiply by 1,000, we actually end up overflowing. And this data, this actually retention milliseconds, it went to Kafka, to librd Kafka, which requires string. So, and librd Kafka also didn't validate that. Well, there was like minus. It just dropped minus, or something like that. Failed with errors, so there were like a lot of errors there. Happily, we didn't affect real customers with that. So we were able to fix it really fast. So what is the problem here? Again, so when we just use multiply symbol, it doesn't check for overflows, right? So we just think it would be okay. Well, this is the proper fix for that. Don't use bad types. So if you want to show what duration is, just use duration type. Yeah, this works. Another solution for that, maybe not particular for that problem, but generally how we should work with it and how we set up our Clippy checks, is to disallow such operations, disallow unchecked arithmetics. Always use checked operations. Because of that, so because we don't know when data will be overflowed. So if there is overflow, actually you should make decision, return the error or panic. Yes, this is again that slide about our Clippy checks. There are a lot of them additionally to that, everything just to make things a little bit more stricter than it is by default. And then we go to the very important topic of errors and panics. So these are two examples. So which one is correct?
Both.
Both are correct. Yeah, both are correct. So actually, it's hard to say. And we have like a lot of holy wars inside the team about that. So do you expect your Rust object file is unable to serialize? It's like, OK, you want to respond with the data to the customer, and you can't serialize your data. Yeah. 5 minutes, OK. Yeah. So it's very important to understand when to panic and then not to panic. And this is the interesting, documentation from the Tokyo Mutex. And actually, it's not the only structure that behaves like that. Each time you catch the panic, you may leave the data protected by the mutex in an inconsistent state. And it happens not only in mutex. So actually, panic is a very critical situation. You should never treat panics and Rust as exception. So it is like something which actually should lead to graceful termination of the application. That's how we work in our code. So because we don't know what is the end state after panic happens. That's a very critical situation. That's a fatal error. And panic should be treated as some broken guarantee, contract, or invariant. Something really deep, something really critical, which we expect it should work. So here are examples. Let's say we create a channel and we want to guarantee that we never got invalid data. So for example, here we create a channel, and if we receive buffer size 0, it's an error. We can return panic, or we can rely on type safety here. So we can pass non-zero usize instead of usize, and we automatically fix the problem. It's impossible to pass 0 here, right? So this is always preferred. So always choose type safety over panicking. If you face some situations with impossible scenarios, so for example, we checked here that the length of the vector is 2, so we are sure that we can take the first and the second element from the vector, right? So just try to point where the check is, right? When we define expect here, make sure you point, make sure you prove the reason why it should never panic here. Another alternative here is to try to use pattern matching if it's possible. So here we try to convert our vector into array of size 2, and if it converts, then it's okay. Otherwise, it's an error, right? So this is better than use any sort of unwrapping. So basically, when to panic. If some operating system of hardware expectations are unmet, you can panic. Functions input expectations are unmet. Prefer type safety, otherwise, depending on the situation. If in your opinion there couldn't be error by design, then prove it. Prove it in the code. Write the documentation or do something else to prove it. If you verified something prior to calling failable functions, point to the code where a check is performed. Yeah. Sometimes matching errors may be hard. So this is the example of the real code. Actually, we don't use any how. We use this error, and there could be a complex chain of errors, and it may be pretty complex logic. And I think Rust can do better here. Actually, probably Rust is the best language in terms of dealing with the error, but it's still not good enough. I think there could be a lot of good things to improve.
Data.
True. Few minutes? More. Okay. Yeah, I'm actually finished. So yeah, something about async code. So we should never forget about Tokyo. I'm talking mostly about Tokyo, but it doesn't matter actually. The whole async model is about cooperative multitasking. So cooperative multitasking means that we can run multiple tasks, but it's the responsibility of the tasks to actually yield execution, right? So when we do something like that, something like loop in the async code, you should always think about yielding the execution, because you may end up blocking the executing thread for too long. I mean, asynchronous executing thread. There are other options using blocking thread, use block in place. Otherwise, you may end up with your service just not serving as you expect. So it can hang for seconds, right, and not being able to do meaningful operations. Yeah, this is the example of how we handle this. So actually, a very big problem which I don't see much of work in the community. When we serialize or deserialize JSON, a very typical format, depending on the size, it can actually become a critical blocking operation. So if it's large, just imagine 100 megabytes JSON. So it will block your execution for a long time. So sometimes you shouldn't just serialize or deserialize in line, but put it into the blocking thread. And here's our graphs, how it works in our case. So we have a special wrapper called async JSON. So it actually, based on the size, it decides where to go. So we can see some operations may take 5 milliseconds or more, which is a lot for executing on the asynchronous thread. Yeah. Yeah, that's it from my side. Yeah, thank you.
Amazing. So, first and foremost, thanks both of you for giving a talk. It was their first talk, as far as I'm aware, at least publicly. Or you speaking before conferences or meetups in Russia? Doesn't count.
First tech talk, actually, for me.
So, second show of hands, because that's actually no visit. And a gentle, subtle reminder that you can also give your first talks, and the man to speak to is Roberto, sitting there in the shadow. Other than that, before we get into the specifics of what you talked about, neither of you has actually touched on your origin story, as in what actually brought you to Rust in the first place.
Well, yeah. So my background is mostly in Ruby for a long time. But then one day I realized that it's not something I really like. It's not the technology I want to continue with. It was like maybe 10 years ago, and I started to search for something which I like more. And I passed through many technologies, Golang, Clojure, Erlang, things like that. But I always had feeling that I need something which is strict enough and which guides me in building the code properly. And one day I found Rust, and it's actually that the love happened. So I actually realized that it is what I was searching for.
I did see some of the scars of a person using a dynamic language in your Clippy setup. I was like, this person must have come from either Python or Ruby. And I was overcorrecting on the other side.
Yes, yeah, I agree with that.
What about you, Matilda?
Yeah, I'll lean into Gleb's story in the sense that I also started with Ruby or Rails. And but I was always searching. Like I found articles which said that it's a good thing to learn other programming languages. So I went that way, wanting to learn other programming languages, and then I figured out that I don't have a computer science background. I felt like I have some catching up to do, and some really great algorithms courses are in Java. I wanted to brush up my Java. I have an engineering degree, but not computer science. So I brushed up on my Java and got kind of hooked on Java concurrency. I thought that was the holy grail. Maybe not. It's actually quite tricky. You have to read. You have to read to do it correctly. With Rust, you also have to read to do it correctly, but it's still different and better. And yeah, it was in 2017. I was heartbroken. All of a sudden, I had a lot of free time. I read the Rust book, because what's better fix for heartache than learning a new programming language, right? So, and I thought this is really cool, but I always also thought that it's so niche. I will never work with Rust. I need to invest on my actual career and build on that. But so it happened that about 1.5 years ago, or almost 2 years ago, I started getting managerial responsibilities, and I felt that too many meetings. Maybe it's not for me, or at least I need a hobby. I need something to, give intellectual challenges for myself. Sorry, I mean management is good work as well, but maybe not for me personally. So I started looking into Rust again, and all of a sudden things started clicking. I started feeling, okay, maybe I can be productive with this, and I wanted to see if I could contribute to something. I picked Tokyo, and I managed to find a couple of low-hanging fruits, put in a couple of commits, and with that plus gaming background plus a recruiter that found my profile on LinkedIn, I got my Rust job. So that's the story.
Actually, an interesting segue into that. How many of the people that are here today, first of all, use Rust professionally? If I can get a show of hands. Don't be shy. Be higher. It's difficult to count otherwise. Okay. Roughly 1/6, 1/5. How many of you are using Rust as a hobby, side projects and such? Most of the other ones. We get a complete Venn diagram. How many are just curious about Rust and thought it was a good idea to come here today and have a look at what people are saying? Okay, That's a non-zero set of people. Nice. So I think an interesting question based on that, because I assume a lot of the ones who are using it as a hobby might want to transition into using it professionally. And you mentioned that in your talk towards the end, Matilda, that Matchday is hiring and that Rust is one of the competencies you look for. Is knowledge of the language actually that important? What's your experience like hiring or training people for Rust?
For me personally, language knowledge is hugely important, but not necessarily for the reasons you might expect. My number one reason for asking a candidate or hoping that the candidate has Rust experience before joining a Rust experience full-time is to have written enough Rust so that you know if you like it enough. Because you need to invest in it. You need to invest in your skills. And sometimes it's work, and sometimes you need to have that motivation. So basically, for the candidate needs to know if they like Rust enough to keep investing in it and to be happy with it, because there are developers who, and I know some developers who say it, that they are happier with Python or Go, and good for them.
There was no judgment. She just said, "Good for them."
Yeah, that's my number one reason. I hope that anyone wishing for a Rust job writes enough Rust to know if they really like it.
What they're signing up for, which makes perfect sense. What's the situation is at the Workato? Is Rust a requirement? Is Rust a nice to have?
So when we hire for our team, it is kind of requirement, but we don't necessarily require production experience with it. So mostly, like, yeah, I agree that, well, it's really hard to actually find the person who knows all the, Rust really deeply. So just ask like how pin work, for example, and you will like face 99% of not being able to answer that. Instead, we are looking for solid experience. We are looking for basic understanding of the language, of the core concepts. Sometimes we see people who actually they go into Rust and they think they look like very briefly on it and they think like, oh, it's like Python, it's like C#. They don't go deeply into it. So then you ask questions, they say, I don't care, I will definitely figure out things. That doesn't work. So actually it is important, and you actually see it during the first interview, you see it within like first 20 minutes of the talk that if person is suitable or not for the role. So if they are interested in Rust, even if they don't know the answer, they will go into conversation. They will tell what they are, what they know about that. They will understand what they're missing and things like that. So yeah, it's basically about, I agree, interest, investing some time into Rust, and basic knowledge of the area.
So you touched on pin, yes, which is a fairly subtle abstraction, which I can use a segue a little bit in that direction. How much expertise do you actually feel you need in Rust to be productive on a Rust code base? And I ask this because a lot of beginners, and I speak to many at events and such, always kind of underestimate or undersell the Rust they know. Like I know some Rust, I can do some stuff, but I'm in no way an expert, even after they've written sometimes tens of thousands of lines of code, like no, just an hello word. Because Rust is a large language. Like if you really want to say I'm a Rust expert, and by that you imply I know everything, there's a very tall bar. But it's actually a bar, is that a bar that you need to clear? Like do you find that day to day, you need that much depth of Rust knowledge?
Yeah, I actually constantly see the same pattern, especially for beginners. Then people are focusing on something which is completely not needed for real production development. Like people are focusing so much on like borrow checker behavior. And in real production code, if you don't write libraries, you don't really focus on effective code, you typically end up with using IRC, whatever it is, and you just don't care about most of complex concept. But what is really important is it depends on what you're writing. So since Rust is like multi language suitable for different areas, you can write embed, you can write games, you can write network code, WebAssembly modules, whatever. So you should focus probably on the area where you mostly want to work in. So if you build network services, for sure you should understand how Tokio works. You should understand the asynchronous model. You should understand like differences between synchronous and blocking code and things like that. But it's not that important to understand how ordering and atomics work. It's like completely different world. Yeah, most of cases, you don't need this.
What's the case for you, Matilda? Matchday?
Let's try to define productivity as hard as that may be. So for me, base productivity means that you can write something that works and it's correct, at least after a reasonable amount of hardening. And maybe it's not like horrendously ugly, maybe it's sort of readable, and maybe you complete that in reasonable amount of time. So that's kind of some tolerance levels for what productivity could mean. And we have, so in our team in particular, we are currently 3, the lead developer, myself, and then a guy who jumped from the platform. I never mentioned it, but the platform, the marketplace, is built with Python and Django. And this guy,
that's fine.
fine language and fine framework. But it's true that our servers are just so much more effective than theirs. So and he had been tinkering with Rust in his free time. He wanted to work with Rust if possible, and he made the transition to our team with having written some hobby projects which were maybe not that great, but they worked, they did something. That was enough for him to know he wanted to make the move, and we took a chance on him. So we have onboarded somebody who did not have much idea of how to borrow, so there were a lot of clones in the beginning. I hope this is actually also streamed on YouTube.
It is.
No, but he's done a really good work, and most importantly, given that we were willing to give him the support he needed, he was productive, he was helpful for our team. And we have the experience of boarding somebody who has some Rust skills, but does not have necessarily depth. So that can absolutely be done, and we're willing to do that again if we have a nice candidate. Otherwise, yeah. Does this answer your question?
Yeah, it does. Don't want to drill any deeper. We'll maintain the colleague anonymous for the benefit of the internet. Probably this is a good moment to take some questions from the audience. If you have any, raise your hand and speak loud and clearly. Don't be shy. You listen to 60 minutes of talks, so you must have at least one question. I have a very long list, but I don't want to go down my list. So for the sake of those who didn't hear, what do you think Rust will be 5 years from today?
In the last few years, even last 5 years, I think we've seen huge traction for Rust, to be honest, on the backend development side. And I think experiences like ours show that you don't necessarily have to be Amazon or Alphabet or Discord or Cloudflare, somebody who's working at huge scale to get benefits from Rust. And so I think Rust will continue this victory march, at least on the server side.
So are you asking mostly about this Rust language and standard or market penetration? Yeah, I think in terms of market penetration, it's kind of pretty clear. So we see so many areas there Rust entered just short time ago, like Linux kernel, for example. And I believe it will grow there, and more drivers will be written on Rust. So in the area of system programming, I believe Rust will eat everything else. So basically, it will not happen fast, just because it doesn't move fast in this area. But generally, it will take more and more, bigger and bigger part.
Yeah, to give you a measure, perhaps 5 years ago, so 2019, Async-await didn't exist. If you had to write a network server in Rust, you had to do it with Futures Combinator, which meant you had a very high tolerance for pain. He had one, I didn't at the time. There was one conference in Europe, which was RustFest. This year, I think we had 5 or 6. Rust was used only in the most advanced, risk-tolerant organizations. You'd zoom out today, Rust is used in so many places. The most meetups in Europe no longer have a slide. We like Rust users because it's just too many logos. It's used in so many places that a lot of companies don't feel like they need to remark that they're actually using Rust. Like I speak daily, as part of my job and at events with a lot of companies that you probably know by name that are actually using Rust, and you don't know about that because it works, we're doing it, we don't speak about using Java. Why should we speak about using Rust? Which is, that is success. When it feels like that technology choice is not edgy, it actually means that technology has gained a level of market, and technological acceptance that marks it as mature. And as Gleb was remarking, Rust is entering in a lot of sectors which are known as being slow-moving, automotive, kernel development, embedded in general. So if I was a person deciding on which technologies to invest on from a career perspective, I think Rust is a technology that's going to have a very long return on investment. Like the technology is going to be here for decades because it's penetrating in sectors that operate on the time scale of decades. So if you are on the edge of should I go and read the Rust book, my advice would be yes. Definitely, as Gleb was saying, read the Rust book, don't try, you say, I'm going to wing it, it's not going to work. I've seen many devs, various levels of seniority just crash. I don't read books, I just figure it out. I would suggest reading something. But other than that, yes, I think there's a bright future ahead. It might not totally dominate everything, it's not a zero-sum game necessarily, but I think it's going to be here to stay and it's going to get larger and larger.
Can I ask a question?
Of course.
Yeah, so we're talking about operating systems, embedded automotive server-side development, but there are other sectors as well. And recently I've been thinking that maybe Rust is a little bit, we are behind the hype because there are also reports and blog posts on use cases where Rust may not be that good. One such area, apparently, it's not my area of expertise. I just read the blog post and now throw the question conveniently on your turn.
I know what blog post you're talking about, but yes.
But one is, one post was about indie game development where you have to iterate really fast and everything has to be connected somehow, which is kind of anti-Rust. Or at least, yeah. And another topic was UX, visual user interfaces. So what do you think is the status of Rust and the future of Rust in these areas?
I mean, I'm not a game dev, so my opinion wouldn't be very authoritative. But that blog post touches on a lot of pain points that are not necessarily related to game development. And as you remarked, a big issue in Rust that's the borrow checker really likes tree structures. Like it likes, I own this thing and this thing owns this other thing, but this doesn't go back. As soon as everything is connected to everything else, you find that the borrow checker actively fights you back. Like it makes very difficult to build these graphs actually using references. And you try then to sidestep a little bit the borrow checker by using different memory management schemes, like arenas. That's a very common one. Where you're like, okay, I'm going to put all of my objects into one gigantic array, and then I'm going to refer to them with indexes everywhere. And that makes it so the borrow checker doesn't scream at you anymore because it's just integers pointing somewhere. But then suddenly you no longer have the guarantee that those references are alive. So you might go into that array looking for an object that is no longer there because the memory of the array is there, but the logical object that you're referring to might have been removed, deallocated, moved, something else. So that is a challenge, which is also coupled to some other issues related to the allocator interface in Rust, which is still kind of unstable, kind of not super first class compared to other languages such as Zig, where like passing the allocator around is a lot easier. The issue around UX is somewhat similar to that, but not quite the same. There's actually been a lot of activity in the UX UI department. There's a lot of pretty high-profile projects in Rust. There's Lint, there's Dioxus, there's Leptos. There's Velo and a few others which are actively being developed. And there have been proposals coming from the UX, UI world on how to make things easier. There's a very interesting, I think, blog post is going to come out at a certain point from Dioxus on what they call features they need for high-level Rust that currently are not available, which is currently being discussed in the Rust project Zulip. And a lot of those things will probably go in a very different direction from what Gleb would set up in his project, but actually made some kind of faster development nicer to do. So I don't think Rust is, even though Rust is full stack, so even though Rust goes from the kernel to the browser, that doesn't necessarily mean that Rust is going to win by a landslide at every layer of the stack. I think you need to look at each vertical as its own thing. There's a Rust for game dev, there's a Rust for backend, there's a Rust for kernel, there's a Rust for embedded, and Rust is at different levels of maturity and penetration in each of these markets. And you got to evaluate the market you're interested in. So I can speak about backend. Other people can speak with a lot more, experience about embedded and similar things. Like, for example, backend Rust is doing well, but it's still not, the go-to language. Like if you're writing a backend server in Rust, it's still a tiny bit edgy. Like, why are you not using Go? Or like, why are you not using Java or Kotlin? So that there is work that we can do, and you touched on a lot of the things, right? You need to get a GraphQL API off the hook, and the integration with the most used. Well, one of the most used web frameworks didn't work. And he is trying to get OpenAPI, and so he's going for another web framework, which is kind of less used, just to get that OpenAPI integration working. So all of these are, nuggets of, it works, but you need to do a lot of work. And so that is not the end state that you want for an ecosystem to say, we got it, like this is Spring Boot, go launch it. We're not quite there yet. Anyway, that was a very long answer. Sorry.
Can I add some?
Please do.
Yeah, so I think the important part of choosing technology for these areas, game development and UI, right? It's about the paradigm which is behind the language. And currently, classical object-oriented languages are dominating these areas. So C++, C#, Java, inheritance, all these complex relationships between classes, objects, and things like that. And Rust just chose different paradigm. So it doesn't follow this. It actually prioritizes safety, pretty simple but strict structures over it. And the question is like, if it's suitable for this area. So if these decisions are suitable for the area of game design or of game development, of user interfaces and things like that, we may end up in a situation that Rust just not suitable for that. So then it won't work. But yeah, generally I think that if game development, I guess there are some frameworks there, but nothing big. But in the UI development, there are a lot of activities actually, and pretty nice.
Probably one of the most visible one is Cosmic, which is the UI environment for Pop OS, which is written in Rust. So things are happening. The Z editor as well. So there are examples of Tauri is another one. So there is a lot of stuff happening. Anyway, question from the audience here.
I have a question to Gleb.
Specifically.
So before, when you explained that, when you build your code, that you have you put it to strict, have static code analysis, then you have some checks, and you also have some Python, and then after that you said, and it's not even strict enough. You want it stricter. So do you have the feeling that at one point there's an end, that it's getting excessive, and that adding another layer?
Let me summarize the question for those who are following the stream. It's like, is there an end to the number of strictness checks that you can have? Interesting, the lines have gone down.
Yeah, that's
Momentous moment.
That's a good question. I don't feel that. So the reason is that, you couldn't measure, it's just incorrect to measure your performance as a team, as an individual, just by, figuring out the time you spend building like single pull request, for example. Because the more technical debt you build, the more bad solutions you made, bad decisions you made in the past, the slower you deliver code in the future. You have to actually refactor, you have to deal with bugs and things like that. So the more strictness you introduce in the beginning, the less, you stop facing this slowness over the time. So you kind of it's not like that, right? Really fast at the beginning and then just unable to deliver anything. You're just moving with the same constant velocity.
I actually want to go a little bit into that. You showcased throughout the talks a few examples of what I call type safety, as in domain modeling through types, which is a very nice concept that you can port across different programming languages, but in Rust works quite nicely as in most functional programming languages. An issue I've personally had in the past with that kind of approach is that composition of guarantees doesn't necessarily scale. Like, for example, you showcase a number that should have not been 0, and you have non-zero usize. What about a number that needs to be in between a certain range?
That's a separate type. Yeah, you just create a separate type, macroses, whatever. So it scales, it works. Okay. Well, in our case, it works.
Yes, is the answer. I'll take that. I think there was a question, yes.
Just ping-ponging off of that. First, Luca, your book, Zero Cron, is awesome. So
thank you.
So you mentioned already that you have Bolero in there, so you have property testing in there. Yes. So when you're talking about your flag, where it can be either on or off, then we know properties about this. It's either on or off. It's never both. Why does that need to be in the language? Why isn't that just a property that you test for, and it's not technical debt, and the knowledge is carried forward to future developers, not to throw copy in there? Is copy something you opted into?
Let me repeat the question as always for the stream. So at what point something needs to go into the test rather than the language, and in particular for the copy example, why is that a problem?
Well, I think each technology has some soul, some basic idea inside, and you just follow it. So for example, if you compare Rust with Ruby, as for example, right? So Ruby is about like express yourself, build nice DSLs, do whatever you wish, it will fix everything for you. So you just follow this paradigm when you develop Ruby, and the same have the same properties. You can find same properties in each programming language. And the thing is that Rust properties are about that. So it's about how that's actually, it was mentioned in the first presentation, like how you refactor. It's so nice that you can take the core structure in Rust, change some attribute there, and start a huge refactoring from that. You just run the compiler and see all the errors that appears, right? And then you just follow what compiler says to you. And it actually guides you to build good architecture, which is the most important part of the development of Rust. And not only in Rust, actually Rust just maximizes that. So that's why I think it's important to continue building in this safety and strictness mechanism into Rust compiler. But you always find there always be a limit. In order to go beyond these limits, you introduce more and more things, which goes from maybe other worlds like fuzzing. It came from C probably mostly. So we continue improving our application with this instrument.
There's also various kinds of checkers that you can run. There's MIRI, there's various kinds of verifiers. Kani is one of those, but there are others. So there's a lot you can deploy on top of the type system to kind of prove correctness of your programs. I think there was an hand raised in this area, but I might have dreamed it. Yes?
Yeah, I think it was already briefly mentioned. What do you think about writing an MVP or something that needs to iterate a lot? Choosing Rust, or maybe choose like Python or JavaScript, and maybe later we write it.
So would you write an MVP in Rust? So would you use a faster iteration language? Skip that, Matilda.
Right now, I would go with Rust, because having been immersed in Rust now for some time, even when I look at the .NET stuff, it looks alien. It's so different. So once you get past the threshold of feeling good with Rust, feeling that you know where to put things and so on. I think it's as good as any other language. I think for fast prototyping and MVPs, a full stack framework such as Ruby on Rails or Python Django may have its benefits if the idea is that the same prototyping team builds both the backend and the front end, and all you want to do is to validate a concept or validate if you can get users for your server, for your service, and then you worry about scaling later, basically. That's the traditional story, right, for MVPs. So if you need a full stack framework, maybe Rust is not the choice. It's at least that it's not the only choice, let's put it this way. But for a server, if you feel happy with Rust, go for it. Build with Rust.
I guess another way to phrase that is that actually it's not Rust the language that's the issue. It's more the libraries that you might or might not have in one ecosystem compared to the other. Like if you move your question to something like artificial intelligence and machine learning, you'll probably be a lot faster with Python, not because Python is inherently a better language, but just because it has a lot more libraries. And so you don't rebuild as much stuff. You just do the thing that you want to do.
Yeah, and also choose whatever works for you the most. I mean, if you know Python, choose Python for MVP. So there is no reason to do anything else. Actually. If you want to use this MVP to learn Rust, then go ahead and do this.
Question down here.
I have a question more in the, let's say, DevOps/operational side. Is there any notable differences of kind of, deploying and maintaining a Rust service in production compared with other stacks that we have? Not only necessarily on the deploy side, kind of no downtime deploys, those type of things, but also in the observability side, capturing of sort of events and getting those properly tracked in tools and so on. Is there anything you would say about that?
To summarize, is there a difference in the way you operate a Rust service in production? So observability, deployments, CI, I assume as well.
In terms of libraries, so typically you need something like Prometheus, OpenTelemetry, what else? Sentry maybe, and things like that. So everything is there. So just take the necessary crate. They are stable, they are good, they are working. So in terms of, for example, Kubernetes, so you will need to build the image. And basically, it's not really related to the programming language, right? So you should just you should just implement some guarantees, like how you react on signals, how you initiate graceful shutdowns, how you control ready and liveness checks in your applications, and how properly you integrate it with Kubernetes and things like that. So generally, since what I talked, yeah, we are very reliability part is very important for us, and we don't face any issues in here.
Yeah, when you use images or containers, the virtual machine does not really care what is being executed as long as the recipes work, so to say. One difference we notice is that our marketplace needs a lot bigger servers than our Rust game servers. So we notice that difference, definitely. So Rust is more resource efficient.
I think a few more things to note there. I think one big difference is performance profiles, which is not really about being faster or slower, it's about being less spiky. Since Rust doesn't have a garbage collector, most Rust services under constant load will have more or less constant performance. And that makes it a lot easier to design alerts, or generally to detect, even looking at the dashboard when the system is behaving abnormally. Very often, at least in my experience working with GC's language, you look at a spike in latency and you second guess, is this a problem? Is this something I need to engage with? Instead, in Rust, if you have a service with a certain performance profile and suddenly latency goes 4x, you have a problem. It's just a fact. And so you go in and try to troubleshoot. On the other side, so not on the as positive, some of the technology that has been perfected over the past decades for languages like Java or C# is not available for Rust. If you want to profile your application in production, that's not going to be as easy. If you want to take a memory dump, and then open it in a fantastic tool and look at what was there, equally not very easy. So the observability tools, metrics and logs, all this kind of stuff is going to work beautifully. But if you need something a tiny bit more sophisticated, it's not quite as the, rosy story yet. Now, most applications never need that, but if you do, know what you're signing up for.
Yeah, I also wanted to add a couple of points. So it's also important with what you are comparing this, because, so for example, if you take Erlang, it's just beautiful in terms of how you can debug it, right? So you can attach to the REPL, and it's actually a full cluster. You have all access to internal structures. You can debug something on real production. So this is like a very specific to Erlang, for example, right? We don't have this in Rust. Probably the best thing we have in Rust is Tokyo Console. But yeah, it's kind of not
There's
not
a big difference.
Yes, there's a big difference.
It's a big gap.
Yeah, and another point is that if we compare Rust with, for example, Python or Ruby, it's not like completely comparing Rust. It's like Rust plus ecosystem with what we have in Ruby, for example. So it's significantly easier to run Rust, because Rust application is self-contained. So there is a web server inside. You build whatever you wish, TLS termination, so anything is like really easy. With Ruby, for example, typically you need to run some Nginx as a sidecar, all these things, which is really painful. So, yeah. So in this sense, like, it's better.
I think there was another raised hand somewhere. Yes.
I would like to know a little bit more about the scale you're working at, if possible, or maybe like what access patterns you have. Do you have like bursts that you need to support, how fast you need to respond, that kind of thing. And if you've made any like architectural decisions based on bottlenecks that you've seen, if any.
Yeah, so different projects have different patterns. To be honest, not sure if I can like share exact numbers. These are internal projects, so I would be.
Most people on a panel would respond like that to the question you pose, like can answer.
Yes. But yeah, absolute numbers. So I'm not committing on that. But regarding the designing for spikes, yes, that happens. So we can face some clients which produce like 10x load compared to something average, and we always design for that.
But I think none of that really affects the Rust side of things, right? Like most of the design for scale and bursts is around how you scale, data stores you use, which wouldn't change that much between one language and the other.
There are some aspects which you should always pay attention to, like for example, memory consumption. So as I mentioned, like for example, we can end up, so if you're not designing things properly, we can end up generating like 300 megabytes JSON. So which is not really good. So it will just block the runtime and consume all the memory. So with multiple parallel requests. So we should take care about this. We should care about yielding and not executing blocking operations in Tokyo and things like that. Limiting pools. Actually a lot of aspects should be covered in the application, but also a lot should be covered in architecture-wise in terms of like external components, databases, things like that.
Any other question while we wait for the food? Oh, there's one there.
Do you know and see any new language that you think that is going to compete in the future with Rust?
Do you know or see?
No, do you know and see?
No, do you know and see any programming language that's coming up that might compete with Rust? And there were some suggestions from the audience, but let's
I believe Zekas is the one. Then I don't remember the name. There is another interesting like early stage language specifically for machine learning. What?
Mojo.
Mojo. Yeah, Mojo is interesting for machine learning because Rust, I guess, it's not there. I don't know.
I'll be honest and say that I don't have anything to add on this topic. I'm just happy with Rust for now. Not looking to the next if the lawn is greener on the other side.
I am, you know, I'm a little bit of a language nerd, so I keep tabs on what's happening. I think there are languages coming up like Zig, Mojo, June, who compete with Rust in some specific niches. But I don't quite see another language that's coming to Rust competing across the full spectrum. I don't see quite anything else in that direction.
I think any new language entering the space will face the same ecosystem questions as Rust is facing. So that is kind of an evolutional topic that either needs to be solved by a tech giant who wants to invest in a specific language and put a lot of resources in building that ecosystem for them, or we have the same kind of a very, very diverse, sometimes patchy kind of an ecosystem that Rust has, where all the flowers can grow and flower, but yeah. So that would happen with the new contender language as well, and then of course, yeah. So maybe this is a likely scenario that there will be more niche languages even.
I think so. I mean, most of the languages that are coming up are niche in some definition, right? The whole existence of Mojo is I want to take a bunch of Python code that looks like Python, and I'm going to build a superset, and that's going to make it so that a bunch of AI stuff is going to run faster, and you will not have to retrain basically your machine learning developers. That's extra niche, but you know, as a market.
I also want to add that, in my opinion, we shouldn't treat Rust as a kind of a standard just like that. It's not just like a syntax grammar or things like that. So the biggest part of Rust is actually how decisions are made, how it's growing, how it's keeping its backward compatibility and things like that. So even if you see some language which are fast enough, maybe they have some good interesting concepts inside, but the big question is, can they grow properly within years and keep backward compatibility, keep being not introducing some backward incompatible changes. Like for example, we see this Python thing like Python 2, Python 3, right? They're incompatible, and this is a big issue. Now maybe not an issue anymore, but it was a big issue for a long time. And so somehow Rust grows properly. So somehow they can make decisions where backward incompatible changes are not introduced as addition things, things like that. So they are just great. And this is important. And in order to compete with Rust, you should also cover this, not only like build nice syntax.
The caveat to that is that it mostly applies to a standard library. I wouldn't quite say that the ecosystem is at that level of like rock solid, never make backward incompatible changes.
Semantic versioning works.
Yeah, it does, but you remember when Tokyo went from 0. What was it? 2 to
0.2? Yeah, that was a short period. 0.
That was a seismic shift. You have to update everything, and we've been through similar kind of seismic shifts over the years. So
I remember I created pull request and request to update to Tokyo 2.0. It took one evening.
Well, the problem is that you need to do that across 200 dependencies. Like I remember we had a Jira epic. It was like update to Tokyo 1, and we tracked all the different libraries to make sure that we could actually update applications. And this is going to happen again, right? Like Rust, the language evolves in a backward compatible fashion. But when new features, enter the picture, then libraries redesign to use those new features, and sometimes they break their interfaces, and then this has ripple effects. So stability comes with a caveat, I think. The language is stable. The ecosystem depends on what you're building on. Although a lot of stuff is releasing 1.0. Embedded HAL has gone 1.0. Tokyo has gone 1.0. So we're seeing...
I think they have some guarantees about changing interface for 5 or something like that.
Oh, it almost expired, by the way. I think we're at the end of that LTS. I don't see Fran anymore, so I don't know what's the situation with food. I'll keep going with questions. We good? Sweet. What's the situation with food? Ah, cool. Beautiful. So we can take one last question, and then we're going to wrap up the panel. Everyone's like, I'm just going to... No. If there's one last question, I'll take it now. Otherwise, I'll happily leave you go towards the banquet. Everybody decided the question is not important enough to be between this room and that food. So thank you everyone for attending. Thank you again to the speakers for participating. Nice to have you here. We have this space until 10, so feel free to stay and chat. I'll be around. I assume the speakers will be around. We're more than happy to discuss further.